different way. Let's say I cut it this way. So now I'm going to get that shape, which is an oval, or in math we call that an ellipse. So can you see by cutting the cone in different ways, I get different shapes. And that's what we're going to be talking about today. That's kind of what we're doing. Those are the conic sections. Now, before we get into the four main shapes we're going to talk about in Chapter 5, let's talk about a couple ways to cut the cone that we don't really care about. For example, here, if I cut the cone exactly in the middle, I'm going to get a point. Cool. Not really much we can study about a point. So that's one of the ones we call the degenerate conic section. Basically means it creates a shape technically, but it's not very special and we can't really talk about it. So we don't really talk about a point. Second one, if we cut the cone this way, we would get a perfect line just straight across the edge of the cone. Once again, that one's degenerate. We've been talking about lines since junior high, middle school. We don't need to keep talking about lines, so we're not going to spend time on that one. And the last one, if I cut this cone perfectly vertically, I'm going to get two sets of intersecting lines, which, once again, I don't really care about. We've been talking about intersecting lines for years. So those are three shapes that you can get from cutting a cone, but we're not going to spend time talking about because they're not really important. There's not a whole lot we can do with them. So let's move on to our first shape that we do get by cutting the cone, and this is if we cut the cone perfectly horizontally. So if I cut this cone horizontally, and then I look at the shape I get, and I could cut it horizontally anywhere. It doesn't matter where I cut it. If I cut it perfectly horizontally, and then I open it up and look at the shape I get, I'm going to get a circle. So I'm going to highlight circle. This is my very first shape, conic section shape that we're going to talk about. We're going to talk about circles more in 5.2. But for now, let's just introduce a couple vocabulary terms with circles. The important thing about circles that we need to know about are the radius and the center. Radius and the center. Those are the two things we need to know for a circle. Now, the last thing I want to talk about with a circle before we move on to our next shape, because once again, we're just introducing the shapes in 5.1. We're going to talk about each of them more in detail in the next lessons. But if you turn to your reference formula sheet in your workbook, remember this is the formula sheet that you will get on your final exam. So these are all the equations you don't need to memorize. However, remember, none of them are labeled. Some of them should be familiar. We have our PERT formula, we have our rate of growth and decay, we have our compound. Those three you've talked about so far. Now, this set right here, don't stress about. We're not talking about those this chapter. Those will actually come up in Chapter 7. So the ones we're talking about today are these bottom ones. And what I would like you to do is to be able to look at these equations and know which shape they go with. So, and the first shape we introduced right now was our circle. And the circle, the only important things are the center and the radius. So if you look at the equations on this sheet, which equations use a center point, h comma k, and a radius r? You could then tell pretty quickly that's going to be this equation. And I want you to actually label it in your reference formula. This is the equation for a circle. And you've got to remember that because remember it won't be labeled on your final. You need to remember what the equation goes to and how to use it. So there's our equation for our circle. Now, the next shape that we can get from our conic section is an ellipse. This was, if you remember correctly, if I took my cone and I cut it diagonally. So if I cut it diagonally, I get this oval shape. It can happen anywhere. Lots of different ovals. Lots of different directions. Just anytime we cut it diagonally, we're going to get an ellipse shape. Now, a couple important things to understand about an ellipse. I'm going to go right here at this one. We have a couple important vocabulary terms. Same as a circle, this ellipse is going to have a center at h comma k. Your ellipse is centered somewhere. Now, a couple new terms that the circle doesn't have. In a circle, we had a radius. But notice, the radius is the same distance from the center point to the edge. Ellipse is not going to have the same distance all the way around. That distance changes. So for an ellipse, we have what we call the major axis, which is the biggest part of the ellipse, the longest part of the ellipse, and the minor axis, which is the shortest part of the ellipse, the smallest part of the ellipse. So that's how we kind of do it instead of a radius. Now, at the ends of these axes, we have important points. At the ends of your major axis, you will have vertices. Plural of vertex. Two vertexes, or vertices. And at the ends of the minor axis, you will have two covertices. Plural of covertex. And basically, once you know these 4 points, then you can just connect the dots and make your ellipse shape. So those are the big vocab words for an ellipse. Your center, your major axis, your minor axis, the vertices are on the end of the major axis, the covertices are on the end of the minor axis. Now, please keep in mind that all of these will change if your ellipse looks something like this. Your center is still in the middle. However, now your major axis will go this way because now that's the longer one. And your minor axis will go that way because that's the shorter one. And now these are your vertices. And these are your covertices. So just keep in mind that will change. And we'll talk about how to know which one our ellipse is when we get more into ellipses, I believe in 5.4. Now, one last vocabulary term with ellipses before we move on, and that is this very important term right here, the foci, or foci. I never really know how to say it. We have two focuses, or foci. Now, let's talk about what these foci do. These foci tell you how round or skinny your ellipse is. And we'll talk about how to find that more with eccentricity in 5.4. But for now, know that they are an important part of graphing an ellipse. And we'll talk about how to calculate them. You'll have formulas for them. All of that stuff will get there. But for now, here's what I'd like you to understand. If you have these foci, and you take from one focus point to any point on your ellipse, and then you go from that point to the other focus, if you add those two distances, it's going to be exactly the same at any point on the ellipse. So if I added these two distances, so this one plus this one, it's going to be the same number if I picked this point and I added these two distances. So if I did this one plus this one, it's going to be the same amount as this one plus this one, which will be the same amount as this one plus this one, which would be the same amount as this one plus this one, which would be the same amount as that one plus that one. You can pick any point on the ellipse, and if you add the distances between the foci, you're going to get the same number. And that's kind of why the foci are important. They help us get those numbers and make sure the ellipse is rounded the way it's supposed to be. So that's all we're going to talk about for an ellipse. We have all our important vocab terms: center, major, minor, vertex, covertex, and the foci. Now, the last thing we're going to do with an ellipse before we end this video to talk about our last two shapes in our last video is go to our reference formula and identify which equation we think goes with an ellipse. Now, if you look at this one, notice that our ellipse is kind of similar to a circle. It's very similar to a circle. It's just not the same radius out in all directions. So our equation should be kind of similar to a circle, meaning that both x and y should be squared, which immediately takes out these equations. In this one, only x is squared. In this one, only y is squared. Can't be an ellipse. So means I've either got this one or that one. Those are the equations where both x and y are squared. Now, remember that we said if we add the distances together, they're the same. That's your key to knowing that this is your ellipse equation, because I'm adding those together and it always equals 1. So this is our ellipse equation, and we'll talk about it more later, but these two are your foci equations. And we'll talk about how to use those when we get to them in 5.4. But that's what I want you to label on your reference sheet. This is my ellipse equation, that's my equations to get the foci. So now that we've talked plenty about ellipses, I'm going to end this video for now, and in the next video we'll talk about parabolas and hyperbolas, our last two conic shapes.